Now that we've solved quadratics by graphing and factoring, let's take a look at solving quadratics by using square roots. So if you remember, square roots are these, and so we need to use them, and then we need to remember how to simplify them. So let's do that first. Let's review how to simplify square roots. So we have a square root of 150. So the first thing we need to do is factor it. Break it down to prime. And so square root of 150, we can think of that as 15 times 10. And we continue breaking it down. 15 breaks down to 3 times 5. And then 10 breaks down to 5 times 2. So if you remember, you have to circle the pairs. So the pairs that we have is just 5 times 5. And then it comes out as a single one. Again, as a single 5. It comes out of the square root. Then we have 3 times 2. Then we simplify that all the way, so we get 5 square root of 6. Okay, so that is simplifying square roots. So go ahead and practice by doing these three below. So square root of 12, square root of 72, and square root of 45. So pause the video, and when you return, the answers will be here. So if you tried it out, number 1, you should have gotten 2 square root of 3. Then number 2, you have 6 square root of 2. So just as a reminder, whenever you get two numbers that come out, it multiplies together on the outside. It's not adding, it's multiplication. And then for number 3, you should have gotten 3 square root of 5. So let's go ahead and try to now solve quadratics using square roots. So we'll do a couple of examples. So we have 3x squared minus 27 equals 0. So we're trying to isolate our x. We want to solve for x. So what we're really doing is we want to isolate our squared value. So isolate the squared value. Isolate the squared value. And so what do we do first here? Well, we want to move the 27 first. Let's add 27 to both sides. So now this is 3x squared equals 27. And the x squared is still not by itself. So let's divide both sides by 3. So now we have x squared equals 27 over 3 is 9. Okay? So now we have our x squared value by itself. And in order to get rid of the squared value, we're going to square root both sides. So square root both sides. So when we do that, we get x equals, and then we get a plus or minus. Square root of 9 is 3. So that's the key thing. Whenever we take the square root, we get a plus or minus value. So our answer is x equals plus or minus 3, or we can write it separately as x equals 3 and x equals negative 3. So let me go ahead and plug in 3 and negative 3. So we'll plug it into the original just to check our answers. So 3 times 3 squared minus 27, does that equal 0? So remember, we have to do the exponent first. So 3 times 9 minus 27, does that equal 0? So 9 times 3 is 27 minus 27, and that definitely equals 0. 0 equals 0, so that is true. Now let's go ahead and plug in the other value of negative 3. So 3 times negative 3 squared minus 27, does that equal 0? So again, we have to do the exponent first. Though negative 3 times negative 3, that's going to give us a positive 9. And so you're seeing that it is the same as we got above. So we have 3 times 9 is 27, and 27 minus 27 equals 0. So notice that when a value is squared, we can use a positive and a negative value. So that's why when you take the square root, when you're down in this area here, taking the square root, we will have a plus or minus value. Because if I plug in positive 3, that'll be not positive 9. If I plug in a negative 3, that'll still give me a positive 9, so it'll make it true. So let's try one more example here. Two more examples. So we have x squared minus 10 equals negative 10. So what we want to do is we always want to set it equal to 0 first. So we oh, not set equal to 0. We want to isolate our squared value. So in this case, let's add 10 to both sides. Add 10 to both sides so we get the x squared by itself. So x squared equals 0. So what we want to do is, again, square root. And so we see that the answer is x equals, we could say plus or minus 0, but we don't need a plus or minus, right? You just say x equals 0. Okay, so notice we have one solution here, and that's it. And then as opposed to the one before it, we had two solutions, x equals 3 and negative 3. So let's take a look at the last example now. So we have negative 5x squared plus 11 equals 16. So we want to isolate our squared value. So what we're going to do is we're going to subtract 11 from both sides. So we get negative 5x squared equals 16 minus 11, that is 5, and then divide by negative 5. So now we get x squared equals negative 1. Now we're supposed to take the square root of both sides, but when we do that, we actually have a negative value inside the square root. If you ever see that, this means that there is no real solution. You are never allowed to have a negative in the square root. That is not allowed. So if you ever are solving something, you get negative inside the square root, the answer will be no real solution. So now, I want you to go ahead and try these 3 examples below, solve using square roots. So pause the video, and then when you come back, I'll have the answers. So if you tried it out, number 4, you should have gotten 2 solutions with x equals 5 and x equals negative 5. Then for number 5, if you tried that out, you would have gotten a square root of negative 2, which means that there are no real solutions to this quadratic. The last one, number 6, if you solve for this one, you add 15 to both sides and it equals 0. And at the very end, you get x equals 0. So that is only one solution, x equals 0. Now let's do one more set of problems, solving using square roots. So this is a little different. We don't have just a regular x squared. We now have x minus 1 raised to the square. We still want to isolate the square root. And so what we do first is we're going to divide both sides by 5. So we get x minus 1 squared equals 5 goes into 9, 1, 18. And then we still want to square root to get rid of the square, right? The squared value is by itself. So now we get x minus 1 equals plus or minus square root of 18. Then square root of 18, that actually can be simplified. So let me do the work here. Square root of 18, that breaks down to 9 times 2. And that breaks down to 3 times 3 times 2. So square root of 18 is 3 root 2. So what we're going to write is x minus 1 equals, I'm going to put a space, plus or minus 3 root 2. So you have to simplify when you can. The last thing to isolate the x is we need to add 1 to both sides. So notice that I left a space here. It is more preferred that you write the number here in front of the plus or minus because a lot of times students tend to mix up where it goes. So please write it in front of the plus or minus. Okay, so that is the answer to this. So what that means is x equals 1 plus 3 root 2 and x equals 1 minus 3 root 2. That is where the x-intercepts are. Let me do one more example. We have 2x plus 7 squared equals 12. And so the squared value is already isolated. So what we're going to do is we're going to square root both sides. So we get 2x plus 7 equals plus or minus the square root of 12. Now we need to simplify square root of 12. So square root of 12 is 4 times 3, or breaks down to 2 times 2 times 3, or 2 square root of 3. So now we have 2x plus 7, and then plus or minus the 2 root 3, because we simplified the 12. Next, we subtract 7 from both sides. So we get 2x equals negative 7 plus or minus 2 root 3. And the last thing is we're going to divide both sides by 2 to isolate that x. So x equals -7 plus or minus 2 root 3 over 2. And that is done. Okay? So I hope this helps you out. And if you would like, you can try these two at the bottom. Not required, but if you want to try out extra problems, you can try these out. Thanks for watching. If you tried these two, these are the answers.